Welcome to C2G Learn Campfire Chat. Today our chat focus is the governance of direct air capture and carbon dioxide storage. Thank you for joining us from wherever you are here. First of all, C2G Learn, what is it? It is an event where we are trying to provide awareness, raising opportunities and learning opportunities for various audiences, for the basic audiences and for people which have dived a bit further into the subject matter. Today, it's one of those which is going to one particular aspect of the large issue which we are overall concerned with. Our events consist of two types. One is a webinar session, which is about learning the status of science, the knowledge, the governance issues, and the Campfire Chat, which is about learning how experts approach, think, what are the drivers as to why they're involved in the in this issue, and so forth. So diving deeper, but more about understanding what people think. Why are we doing this? IPCC special assessment report, even the fifth assessment report of IPCC were very clear that in order to reach the Paris goals, there is a requirement to balance emissions and thereafter reach negative global emissions, that is removing more carbon than emissions which might be remaining. And both need transformational changes, whether this would be the emission reductions or the large-scale removals which are needed by the goals which have been set in the Paris Agreement. So our challenge is not, or the question is not about if we need large-scale removal, it's more about the amount and what kind of options we might have. So it's about designing ambitious emission reduction targets while at the same time exploring and developing societal acceptable portfolio of large-scale carbon dioxide removal that will balance the residual emissions by mid-century and matching thereby any residual emissions which could not be removed or taken care of through the emission reduction strategies, and thereafter provide more than what might be remaining. Without this, the goals of 1.5 and 2 will be fundamentally out of reach. Now, today we are basically focusing in one of the options which are out there to be discussed and to be analyzed, which is direct air capture combined with carbon capture and storage. Again, as I mentioned, these events are not to argue and convince each other. It's about sharing why you have, respectively, our experts here have different approaches or how they approach the same issue, maybe with different arguments, with different perspectives. The views, as we mentioned in the opening slide, is those of our guests. We are here only to facilitate our guests, and I will come to them in a second, as well as your questions which you might have to the experts. Now we have today 4 amazing people joining us. Welcome. They will each introduce themselves in the first round of interactions which are going to happen, but let me just quickly mention the names. We have Ceri Vincent, who is the president of CO2 GeoNet. Welcome, Ceri. We have David Hawkins, senior attorney, climate policy, climate and climate energy program at NRDC. Hi, David. We have Masahiro Sugiyama, who is an associate professor at the Policy Alternative Research Institute at the University of Tokyo. Welcome, Asa. And we have Maya Bates, who is project manager for energy and land use at Nature Conservancy. Thank you all for joining us, for some at very early hours and for some late in the day. Thank you for joining and making yourself available for our listeners. Now, how we're going to go about this, we have basically a first round of, as I mentioned, interventions of our participants here, of our experts. And then we are going to move in a kind of question and reaction session where we do hope that you will have lots of questions up your sleeves and how to convey them to us. We have the question and answer interface, which you should find at the lower part of your screen, a button which you can press. Please insert your question in that interface. We have a colleague, Michael Thompson, who is not visible, who sits in the background, trying to see your questions and kind of bring them together in synthesizing them as necessary. We have also prepared, based off previous interactions, a set of questions which we have up our sleeves in case we do not come up with lots of questions from you as the audience, but we do count on you. We really would not want to keep this for future sessions if possible. So with that, I think the other important point here is do not use the chat box. The chat box is not being monitored. And I think with this, I think I'm ready that I have covered my mechanical aspects of the introduction. So we have, I think we would start with you, David Hawkins, in terms of sharing who you are, and then how your issues now, how you approach the subject. Thank you very much, Dave.
Thank you. Thank you for organizing this and inviting me. I am a lawyer by training. I do policy work on climate change at US-based NGO, the Natural Resources Defense Council. And I'm happy to be able to make a few remarks about direct air capture. First, why is the climate community interested in direct air capture? Kai has mentioned one of the reasons. In addition, I would say that specifically direct air capture avoids the need to use biomass, and that's a benefit because when we humans start messing with the biological systems of the Earth, we tend not to get it right. And I don't think there's any reason to believe that it would be different with some of the biomass-based removal systems that are being thought about. Second, it has location flexibility. It doesn't need to be located next to a large fossil fuel emitting source. It doesn't need a large fossil fuel emitting source because it takes the CO2 from the atmosphere. And third, it has the capability of replacing fossil fuels through fuel synthesis using the carbon dioxide from the atmosphere. So those are three important attributes in my view. DAC is valuable if it's scalable. This is not something where a boutique application will actually serve to protect the climate. So if it's going to be valuable to protect the climate, we need billions of tons of removal. And that brings up, for me, the key issue that we need to address urgently, which is the energy requirement for these direct air capture systems. Currently, they're high, and high energy is a problem. It's a problem because of costs. It's a problem because of land use. If we use renewable energy, wind and solar, to supply that energy. And it just adds to the complexity of deployment. The more energy you need, the more demands on the system. And currently, the energy costs are high. There are current systems. There are two current systems, solvent-based and sorbent-based, to do 1 billion tons of removal of CO2 for the solvent base would require about 2% of current total global energy demand. And for the solid-based system, it's closer to 9% of current global energy demand. If we want to be doing 10 or 15 or more gigatons of removal, you can see that those numbers add up very fast, and it's very important to reduce them. So some policy options to reduce them. We could subsidize to get plants built. We could do procurement requirements, or we could set standards and get deployment early based on standards. The third, standards, is my favorite. I think a very small 1 or 2% carbon take-back requirement imposed on fossil fuel producers could result in tens of millions of tons of projects being started. And it would have virtually no noticeable impact on fossil fuel prices. That's obviously only an initial program, but it's enough to get these pioneer plants built so we can start the energy reduction learning process. Thank you.
Thank you very much, David, for your points. Maya, why don't you follow up with your perspective? Thank you very much.
Hi, everyone. My name is Maya Batres. I'm a project manager at the Nature Conservancy. I want to first thank C2G for inviting me today. I'm really happy to be here talking about direct air capture and climate change. For those of you who don't know TNC, we're a global organization. We're in 79 countries and all 50 states. Our mission is to protect lands and waters on which all life depends. We're about 4,000 scientists policy experts and land management experts who are working at doing just that. So my job is really focused on bridging this science to policy and policy to plan gap. I focus largely on developing tools that help us build out infrastructure to address our climate goals, but also that protect important landscapes across California. So that's where I'm currently in Minnesota, but I'm typically located in California. That's my home state. So when I think about direct air capture, I think really about two questions, and I'm going to talk about those right now, and I'll get into those more throughout the conversation. As David noted, direct air capture can be pretty land intensive depending on the heat and electricity choices that you make in terms of powering these facilities. So when I think about the deployment of direct air capture, I'm really thinking about this in the context of the larger infrastructure systems and the technologies that we're going to need to meet our climate and energy goals, particularly renewable energy, which can be pretty land intensive, as we know, and what opportunities and trade-offs come with the deployment of direct air capture. How do we plan for the development of this technology, and how might this technology be sited in a way that creates the least harm for important landscapes? To give some context for why this question is important, I'll talk about California specifically. So California currently has about 80,000 acres of solar power on the ground right now. TNC has undertaken several siting studies to better understand what the land use requirements of achieving decarbonization might be. We found that in our recent study called The Power Place, we found that California could need as much as 3.1 million acres of wind and solar energy to meet our climate and energy goals by mid-century. So and that doesn't include direct air capture. So when you're thinking about direct air capture deployment, you have to think about what are the other technologies that we're scaling, what are the land use requirements of those technologies, and what are the competing needs for land. I think how we make decisions about powering direct air capture right now is going to be important for the future. So co-location is a great opportunity for us to start thinking about, particularly in California. We have geothermal energy resources that provides benefits in terms of land use. We should be thinking about what are the policy mechanisms to identify those opportunities as early as possible. And then the second bucket of questions that I really ask myself when I think about the deployment of this technology and any technologies is, given the land transformations ahead of us, what are the policy mechanisms and safeguards that we could to deploy this technology in a way that is consistent with not just a just future for people, but also for nature, especially for the communities that have been most impacted by climate change. And excited to get into that a little bit more. Looking forward to the discussion. Thanks.
Thank you very much, Maya. I think this is a good lead into Maza to come in. I think he's zeroing in further in some of those aspects. Maza.
Yeah,
thank you.
Thank you, Kai. Thank you very much for inviting me, and I'm very happy to be part of this discussion. My name is Sugiyama. I'm an associate professor at the University of Tokyo, working for Institute for Future Initiatives. In addition, I'm an IPCC lead author for the DACCS status report, and our chapter covers reviews of direct air capture. So, and I usually work on climate policy integrated assessment, but I know I'm getting familiar with the DAC. And I try to provide some non-Western perspectives, and I think the increasingly direct air capture is being discussed in Europe and the United States, and in the Western part of the world. But there is less, of course, obviously interest in DAC in other parts of the world, at least as of today. But Japan is getting interested in DAC. So our long-term strategy, mid-century strategy, said that we have to, we would like to achieve net zero emissions in the latter half of the 21st century. So that means that we have to do some negative emissions. And with DAC comes up quite often these days. And we have a couple of the R&D projects in Japan, but that's not huge, and we don't have active startup unlike the Europe or the United States. But so like I said, I do climate policy analysis with the integrated assessment modeling, but DAC comes up in the modeling results. And why? Obviously, because we need negative emissions. But Japan is a country with a high population density. And so as David says, DAC has a location flexibility. So we implicitly assume that some DAC place takes somewhere in the world, not necessarily in Japan. And it's very difficult difficult for us to find a CCS geologic storage location within Japan. And I think that's a big headache for conventional fossil fuel CCS. And probably the DAC would be okay. But then there's a question, what if we would like sort of develop DAC, Japanese DAC facilities in somewhere like in other foreign country, of course, upon obtaining a permission from that particular country. Maybe Japan can manufacture a DAC facility in somewhere in desert in the Middle East. Maybe that's good, but I think that would provide a lot of governance challenges. And I think I'm actually happy to talk about these challenges. Yeah, so I'll stop there. Thank you.
Thank you very much, Masa. Bringing in a very national perspective and the challenge about how to actually meet your removal challenges in Japan due to geological and characteristics of population, etc. Ceri, over to you. I think this brings us to the storage aspect of things.
Thank you for inviting me to speak at this event. So I'm at the very far end of the chain. I'm interested in the storage perspective. I've been studying CO2 storage opportunities for almost 20 years now, and it's one of the key options that we have, I feel, to store our CO2, whether it comes from large industrial sources or from direct air capture to enable us to have negative emissions. So capture with solvents has been around since the 1930s. Storage has been around for, 40 years. We've been injecting for enhanced oil recovery and more recently for storage. So according to the GCCSI report, we've stored over 260 million tonnes of emissions from human activity. And that's sort of a fantastic number. But obviously, we see that we need to do more in order to meet our climate targets. So where can we store CO2? Well, if we look across the globe, we see there's lots and lots of opportunities. There's lots of places. In some places, this has been studied and we've actually injected CO2. So we might look at the Sleipner project, 20 million tonnes stored over the last 20 years. We might look at Boundary Dam, which is a commercial CCS project, 2.9 million tonnes CO2 captured. So we see opportunities where CO2 is being captured, being stored. For me, for direct air capture, what I'm really asking is, so should we consider co-locating direct air capture along with conventional CO2 storage so that we can take advantage, as direct air capture develops, we take advantage of the existing stores that are being developed for large point sources? Or will direct air capture be large enough that it's going to be able to have its own stores? As we know, we want the storage to be close to where the CO2 is being captured to achieve maximum efficiency. We don't want to carry it too far. So my interest is, so should we put the stores, should the first DACCS plants be co-located near traditional CCS projects? Where will DACCS work best? Where geographically will we put DACCS given the competition for land resources? And that's come up from two of our speakers already. So obviously we want to know what the future is going to look like and how can we get there effectively? How can we really efficiently store our emissions, reduce our emissions? And how does it fit into the overall picture of all of the options that we need to use in order to meet our climate targets? Thank you.
Thank you very much. This was a very swift, and thanks to be actually on time with your interventions, as we had discussed beforehand. So we have, I think, a very kind of nice lay of the land from the aspects of interest. We see some which are kind of coming out with each of you, which is the question of location of these the energy demands, and then the resulting questions of land use, and the other aspect is, if I may, is the how to drive basically the development and implementation of startups, the beginning of developing the capacity to have a better understanding of some of the questions which you have been asking for. Now, Michael, a quick question. Do we have any questions in the Q&A? I don't think so. All right. Those who are attending, please do not hesitate to ask questions. I'm always saying there can't be dumb questions, only dumb answers. At best, so to say. And I don't expect this to happen here. In which case, maybe I'm going to pick up some of our questions which we prepared beforehand, and maybe we can get into that question. The one question I think was, which you all had about the question of co-location. Why is that so important? What would be like for you the two or three key issues as why co-location is so important? Maybe I don't know who to start with. Maybe Ceri, if you can just follow up. Why is it important?
So I saw an interesting question pop into the Q&A as well, where somebody asked how much it would cost to store to store all of our CO2, and that somewhat distracted me. So I would pick up the lessons from Boundary Dam, where they said they could achieve a 67% cost reduction with their next project. So in terms of storage, it depends where you're storing. Everything's more expensive offshore, but there's huge opportunities offshore. So for onshore in the US, I've seen figures quoted as low as $6 or $7 per ton for CO2 storage. So it really can be quite affordable onshore, depending on the infrastructure and the storage site. So to sequester all of the CO2 we need, I can't tell you that number, but I can tell you that the cost is improving and that it is something that is definitely we need to work on. But as we learn by doing, we will bring the cost down. And the same thing will happen with direct air capture.
Mm-hmm.
Sorry, Kai, would you like to repeat your question?
Sorry, I mean, my question, I think to some extent you covered. My question was about the reasons for co-location, and I think some of the aspects you described is cost. Cost is a big factor. You transport the source of where to pull it. That was, I think, where I was going at. Mm-hmm.
I was also thinking about efficiency for storage, because where we're going to store CO2, if direct air capture is still developing, a good opportunity to do something quickly with the CO2 and to store it would be if we already have an ongoing CO2 capture and storage project that's conventional and we co-locate direct air capture, we could take advantage of learning by doing for a relatively cheap direct air capture project. And then we would already have a store ready to go and developed that could take that CO2. So I was thinking about kind of efficiency and how we could scale up DACCS, because it's still in its early stages, it's still developing, even though some of the aimings are really quite mature. Let's look at how we can develop this technology, because negative emissions become more and more important with every year that passes.
Mm-hmm. Thank you. I think what you just, the last point, basically over the other question or dimension which we had was, and you kind of pointed to this indirectly, is the pathways. Basically, how do we get to what we expect we need? And there were like ideas about getting startups going. There were considerations, I think, in MASA about some of policy considerations of a pathway where you have to go abroad. Maybe if you can have a kind of around the table of what would you see are like your key pathway, what are the most critical points in the pathway going forward in getting the DACCS capacity, on understanding of the DACCS capacity. And I think we are talking in our context currently about attaching storage to it and not use as a form of storage. Let's just focus on the part which looks into storage in the way Ceri has been describing that. Maybe if I may, David, because I think you were the first, I just go around in the circle, so to say, if you could go ahead and talk about that pathway going forward. You mentioned also energy needs, what kind of energy, this kind of questions.
Sure. And first, let me correct, I misstated the energy requirements for the solid-based systems. A 1 gigaton solid-based system, 1 gigaton removal per year, would be about closer to 5% of current global energy needs. I said 9%, but 5% is more accurate based on the published estimates. And that's, I want to underscore that's using current systems, which are very much generation zero. And the purpose of getting some of these pioneer projects deployed is to start the learning process. And the pathway to me is quite straightforward. We need policy to create markets. It is market demand that is going to induce the private sector to spend the large sums of money that are necessary to build and improve these facilities. And market demand isn't going to flow from the free market system. It's going to flow from governmental policies. We need governmental policies that will tell developers, yes, if you improve this technology, there's going to be a demand because the policy requires it. and that is the straightforward pathway that I think we should pursue. For political reasons, it may be. It may turn out in some jurisdictions that for political reasons we need the lubricant of a subsidy, but that ought to be a subsidy ought to be regarded as kind of the thing you use as little of as possible. If you have the political will, it's certainly technically and economically feasible to require a gradual penetration of technologies like direct air capture. And the final thing I will say is that many in the environmental community, myself included, are quite concerned about the misuse of technologies like direct air capture. And what do I mean by that? Misuse means using technologies like direct air capture or other forms of carbon dioxide removal as a substitute for achievable emission reduction. We need a policy framework that does not allow these carbon removal technologies to be used to enable continued high emissions of fossil fuel CO2. And we can do that. For example, there's a recent paper proposing in the EU that the government set a separate target for carbon dioxide removal. So you'd have a target for emission reductions, and you'd have a separate target for carbon dioxide removal, and the two cannot be traded against one another. I think that is a sensible approach.
Thank you. Yes, it's maybe Maya, if I may ask you to follow up on these questions about the pathways or react to David's propositions in this regard. Anything you would like in that context?
Yeah, I think David's right that the accounting mechanisms are really critical. So California has a 2018 executive order issued by our governor to achieve carbon neutrality, but that hasn't been legislated yet. And so we really don't know what role, if any, direct air capture should or could play in achieving our climate and energy goals. And a lot of it has to do with the conversations and the complexities of the accounting mechanisms and getting people to agree on what is the appropriate standard for direct air capture. I want to paint maybe a broader picture of what it looks like and some of the challenges that I've thought about in scaling this technology in my jurisdiction. So there are two geographies in California that show promising geologic storage potential. One is in Southern California, and this tends to be a place where a lot of fossil fuel is produced. Potential opportunities for co-location of direct air capture there. In Northern California, however, where the second geography that shows CO2 storage opportunities, there's a lot of agricultural land and a lot of really high value agricultural land. And so thinking about co-location, one of the things that I think about is how do we manage for the need to produce agriculture with achieving some of our climate goals? And so then, I go to, okay, well, let's try and put the direct air capture maybe a little bit further away from some of these high value agricultural lands and either pipe in the CO2, transport it by car, bring it in by barge, by rail. There are several transportation options. But I think critical in making those decisions is thinking about the air quality implications for the communities that are impacted by the transport. And if we're doing pipelines, what is the real feasibility of getting that pipeline infrastructure built in a reasonable timeline, given some of the infrastructure challenges that we face in California specifically in terms of siting, permitting, and deploying these technologies? So I wouldn't say that I push back on it, direct air capture being location flexible. It's just that there are a lot of other considerations that go into deploying large-scale technologies that don't have to do with just plopping the technology down in one place. Some of the places, particularly in the Central Valley of California, face some of the highest air quality pollution because of transportation of biomass and agricultural waste. And the last thing that we want to be doing is adding to that air quality problem by transporting CO2 through trucks through those areas. And so when you think about location, you have to think about more than just can this technology be placed down, in any given place. It's really about what are the impacts to the communities when you do site these facilities, the energy that goes with them, and then the infrastructure that you need to transport the CO2.
Thank you very much. I think if I may ask you, Masa, because I mean, what Maya just described in terms of the challenges of the location question mark, I think it's and how this is relevant and important to have the local population being part of the decision making and being in the consideration sphere, so to say. I guess this is slightly more complex if you actually are, I will say, forced, for lack of a better word, to find service providers abroad which would do that job for Japan the way you're describing it, and it's as bare as that. What have you thought about in terms of? And you said you had a few thoughts about the increased challenges if you need to go abroad for this for finding the removal opportunities with direct air capture. If you maybe elaborate a little bit on that.
Well, yeah, thank you. So first of all, of course we have to obviously scale up the DAC and these companies must incentivize. I totally agree with David. We have to create a market, but there are many different ways to create markets. So obviously one is carbon pricing, but the government can procure the DAC services, and there are many ways to create a market. Let's say Japanese government does something like that, and it forces companies to do DAC somewhere. And but I think there's some relationship between the fossil fuel, like enhanced oil recovery, or sort of how can I say, the fossil fuel industry part and the DAC. There are a lot of heavy industry companies in Japan, and which have such technical capabilities. So they can work with some of the startup company in Europe or the United States and create a facility in some the Middle Eastern countries, and they do that. For the oil and the gas, these kind of industries. So it's theoretical possible, but I think the question is, I think here again, it's about scale. So once you start doing that, it's going to occupy a big portion of land, and it can affect some ports and the coastal lines. It could theoretically. So these countries do not necessarily have strong governance schemes. So even if you build something in the middle of the desert has its ecosystem, and it had some the plants and the animals. So we have to safeguard some of these sort of side effects of the DAC scale and upscaling, I think. But I think if I step back, I think the most important challenge right now is the scaling up the DAC itself, not the dealing with the side effects. Maybe you guys, people might have different opinions, but the industry is so tiny, and if we don't give them enough support, they will die off, I think.
Well, any immediate reaction to that die-off risk?
By the way, can I say one more thing? So there was a question in the chat box about the cost of DAC, and the estimates are everywhere. So it could be as low as $60 per ton of CO2, or it can go up to $500 per ton of CO2. There was a bit old estimate which said $1,000 per ton of CO2, which is a bit outdated, I think, but right now it's quite expensive, and even if we are lucky, it's gonna be quite moderately expensive. $100 a ton of CO2 some technological optimistic people say quote even lower numbers, but it's not gonna be very super cheap technology. So the government, there needs to be a market for that. Otherwise, the free market wouldn't solve this problem.
Well, as we are at the cost estimates, and as you mentioned, there's, I think, the question about what would be the total cost of it was also one of the questions. It all depends. There's a relationship of how much we are successful in the emission reduction strategy, I guess. So there is a link, and with these cost estimates, one multiplies with the 100 to 1,000 gigaton removal requirements by the end of the century, and one has roughly a figure. And I tend, as a political economist, I tend to say, well, a cost is also the earning of someone. So it's a more direction of where and who and how you make your living than necessarily that there is a cost. But I mean, that's difficult. It's philosophical as a reaction, I guess. There were two things I wanted to come back with. One is, I saw David, you raised, and I will get to you in a second. one dimension that I would like to cover. I mean, we have talked about storage. Are there different forms of storage? Is there a gaseous form? Is there like what are the differences? And also the questions, are there forms of storage which represent a use? If somebody, a bit later on could come to that, I would give you the hand, David. And the other one, we talk about the energy requirements. If you look at on the emissions reduction strategy side, if you look at IPCC pathways, even in the most ambitious climate emission policy and action pathway 1 of IPCC, the amount of nuclear is already increasing a lot. So the question is, if we were to add nuclear also, for example, in the use of this, what is the nuclear question in the question of how to find energy for these systems? So maybe with these two things, I will, as you raised your hand, David, if you have something, maybe you could come up, but maybe I would like to come back to these two questions through whoever raises the hand after David.
Thank you. I wanted to circle back on the location flexibility and say that I completely agree with Maya's points. The point about location flexibility doesn't mean that you can locate these facilities anywhere. It means that these facilities can work technically in many more locations than other forms of CDR, or in contrast to carbon capture and storage, which has to be co-located with the emitting source. So the fact that these facilities have more location options means that you have a greater ability to avoid the conflicting locations. You don't have to put these facilities in places that are already burdened with air pollution. You don't have to put them in sensitive ecosystem areas. And you don't have to locate them far, far away from geologic repositories to get to your point about storage. So that's the location flexibility benefit that I just wanted to mention. And I know Ceri will have much more to say on storage, but let me just say this is a very important governance issue. Technically, we know how to store CO2 in secure geologic formations, essentially permanently. Geologic processes work to turn injected CO2 into rock over time, provided that it doesn't leak in the meantime. And that means you need formations which are leak-proof. Those formations exist. That's why we have oil and gas today. And we know a lot about the geology of secure formations. Obviously, when we start injecting gases, we disrupt the natural formation, and so it needs to be managed. And that's where policy again comes in. We need regulatory regimes which impose operating requirements on injectors. We need transparency so that the public has access to the information. We need monitoring and verification. All of these things are easy to do technically and economically, but they do require political will to make sure it happens, and they require resources to make sure that the regulatory agencies are well funded.
Thank you. I had Ceri first and then Maya.
Okay, thank you. So I thought I'd drag us back a little bit to where can we store CO2. So there's lots of different potential options. The most popular are storage in depleted or depleting oil and gas fields, or saline aquifers, which is basically where you've got deep rocks full of salty water. So in terms of locations, we're often looking near to oil and gas fields because we'll have data, we'll know a bit more about the area. We might have rock samples, we'll have wells that prove how well these formations seal, how well we can trap CO2. So we're looking for an ideal storage formation at a depth of maybe 800 meters to maybe 2.5 kilometers, depending on the geology and where we're looking. So we can't just store it anywhere. And one of the ideas for me is, well, we want to be as efficient as possible. So, okay, we can't just plonk direct air capture wherever we like. Obviously, we have to be sensitive to where it goes. But what I'm kind of thinking is, well, if we've got a CCS project going, chances are it's in bringing CO2 from an industrial source, an industrial area. Can we piggyback a small DACCS project onto that? Can we take advantage of that? Obviously, you raise some very valid points, David, in terms of storage. In Europe, we have the European Storage Directive with 4 guidance documents to tell storage operators how storage sites should be monitored, that we must provide this assurance to the public that it's being done properly, that it's being monitored effectively, that it's properly regulated, that it's being done as safely as possible. We have to make sure that we can answer for this, to make sure that we are doing this well. There's an awful lot of effort goes into finding a good storage site, to monitoring it, to providing the assurance to the regulator and to the public to say that, yes, we are doing this well. If we're going to put all of this effort into capturing the CO2, there's no point putting it somewhere where it's not going to stay there. So obviously this has all been stored. We know a lot from the oil and gas industry. We know a lot from places where CO2 is naturally trapped. There are natural CO2 accumulations. If you're drinking Coca-Cola in America, you may have got some CO2 from the McElmo Dome, for example. So there's areas where we see natural CO2 stores. So we learn a lot from all of these analogues. And then we start doing our own CCS projects, and those teach us even more. And we look at, for example, this research site like Sleipner, that has got every form of monitoring and verification technology you could think of. They've tried gravity, they've got regular seismic surveys, they've thrown everything at it because it's a research site and they want to know everything about it. And then we look at a commercial project like Boundary Dam and they start to say, well, what's the most effective monitoring? We have to do this efficiently. They have to be able to make a profit. It has to be a commercial project. And we start to ask, so what's the most effective way to monitor to this site? And again, it's thoroughly regulated, it's thoroughly monitored and verified so that we see the CO2 storage site is behaving as it should. And I think that's kind of the most important thing for us, is learning by doing, making sure that we do this well, we do this responsibly, because there's absolutely no point in storing the CO2 if it gets back out again. So thank you. That's what I wanted to add.
Thank you very much. Then over to you, Maya. You had your hand up. Thank you.
Yeah, so I think we've made some really good points about technical feasibility of this. And I feel like I need to caveat everything I'm saying by, I am not a non-DAC supporter, but I just think in the development of some of these projects and, TNC as a landowner of CO2 storage has been thinking a lot, not just about the technical feasibility, but the legal feasibility and the responsibility that goes with storage of CO2. So, I think we're starting in the US to see these cases, legal cases pop up around pore space rights and how do you differentiate pore space rights from mineral rights. But a lot of these are very unprecedented issues. How do you value pore space rights? If you're a landowner who has pore space, how much money can you charge to store pore space? How much should you sell your pore space for? Who's responsible for it long term? So we certainly have some requirements through federal regulations and in California through state regulations like the low carbon fuel standards, which require a 100-year monitoring requirement for storage. But who's responsible for it in the long term? And let's say you enter an agreement to lease your pore space rights. Does the fact that it's permanently sequestered underground really make it a sale of pore space rights versus a lease? So in addition to the technical feasibility questions, I think we just have this totally unprecedented area of law that we don't fully understand yet. And these are some of the questions that if we want this to get to scale, we need to start thinking about right now, not just from is this technology capable of achieving some of our climate and energy goals, but what are the policy mechanisms that we need to enable this to be successful from a landowner's perspective, from a community perspective, and as I've mentioned several times, from a biodiversity perspective, ensuring that this, if we have a leakage event, how do we protect the landscapes and the people who are going to be impacted by it?
Thank you very much, Maya. I saw, a question which is somewhat linked, because we talk about bringing to scale with all the challenges of, putting in place the right policies, the right considerations, and so forth. There seems to be potentially limitations just by that perspective, but there is, we have in our Q&A a kind of a rough estimate of what would be required. I don't know what the basis is for the for what the calculation is, but it's clear that DACCS is not going to be likely in any case, we don't have silver bullets anymore. It will be part of a combination of a portfolio of removal. If you had to think about the kind of challenges which you see, and you are certainly familiar with other removal approaches, how would you rank it in the terms of the most promising options in that scale, and what would be like the factors you would take into consideration in this context? Who would have a thought or view about this? Ceri.
Okay, I'm going to be bold here and say that I would put direct air capture as a removal option underneath conventional CCS. For me, we've got a lot of experience of capturing CO2 where it's concentrated, and that's very efficient and very cost effective. So for me, I think capturing the CO2 from a large source would rank above DACCS, simply because it's easier and more effective. So I think let's do that, but let's not ignore direct air capture, because things change very, very rapidly, and if you don't give new technologies a chance, you'll never know what they could have achieved.
I want to just quickly follow up on this one, while others might have developed their other views, other points. Is that you said focus first on carbon, the capture at source. Which the question here, I think, of the debate here is this actually contributing to the removal? If you take the separate goals perspective, right, that we work on emission reductions and we work on removal opportunities, I think there are people who would argue that the traditional and how it emerged carbon capture and storage at source, whether this is oil production or large industries, is actually a means of the emission avoidance or emission reduction strategy rather than actually a removal strategy. It doesn't take out greenhouse gases which are in the atmosphere and brings them, cleans up the atmosphere, if I must to say. And I think that's maybe what are your thoughts in that space?
Yeah, that is a fair argument. I guess for me, I'm just thinking about if we're avoiding getting that CO2 into the atmosphere in the first place, let's focus on that. So I agree, you could argue a little that perhaps I'm looking at avoidance rather than removal, but I still say, well, if we've avoided it going into the atmosphere, that's a good thing.
Yeah. Oh, and I think there's no question about it. It's more that there's this clarity, and I think, we all know how difficult it is to clean up your room once you have created a mess in it, and you regret that you created a mess in it. That's at least what my kids always said. I never said this. David.
Yes. Well, first, I just want to agree with Ceri's last point. There's the rule of holes. When you're in a hole, the first rule is to stop digging deeper. And that means stop emitting additional tons into the air. So emission mitigation is the top priority. Emission avoidance, emission reduction is the top priority. But if we're going to address the climate disruption that we are already seeing in the headlines over the last few years, we need both emission reduction and carbon removal. And that's where these technologies come in. So, we have choices, and the choices are not limited to emission reduction or carbon removal. There's a third choice, which is tolerating additional unacceptable suffering for the world. And we need to have all three of those options, if you will, in the picture. And for me, we need to minimize suffering, and that means maximizing emission reduction and maximizing carbon removal. Do both of them.
Thank you, David. And I think that's also to a large extent what we read from the IPCC. It boils over in any of our conversations, is that governance is also about considering the scenario you talked about, and that would also be a world where we have to probably invent and deal with governance challenges which we might want to avoid in the first place, similar like the emission reductions. We kind of having, it's coming up again and again. I think Maya, you made several times the point about the social license for this technology. What is kind of your first kind of 3 or 4 thoughts you have if you think about social license? What is the likelihood for it? Maybe some of the experience you might have had in dealing with it around the test projects or startup projects which have taken place. Who would like to react to that question? Maybe Masa first?
Sure. I think this is a very important consideration, and actually this is related to what the point Ceri made about the conventional CCS versus direct air capture. And I think if you look back at the old IPCC reports, they were saying that we need we have to equip the coal-fired power plants with CCS, and that would be almost like the cheapest option for mitigation. And IEA and basically a lot of scenarios emphasize the conventional CCS. But the reality played out differently. And I think one of the consideration was social license to operate or public acceptance issues. So I think a lot of countries faced this issue. And the CCS, we couldn't come up with, this is my feeling, but the people couldn't come up with a way to address the public acceptance issue when it comes to CCS, because the conventional CCS must be co-located with the source of emission. That's the key difference. So in the DACCS, we have a location flexibility. And so this is good and bad, because I think we can, in the optimal world, in the ideal world, we can choose the best place for the direct air capture in terms of side effects and biological, biodiversity considerations and other things. And of course, it's an energy intensive technology. So we have to create renewables, power plants surrounding this DAC cap plant. But we don't live in the ideal world, so we don't know where. I think the companies will flock to where they find incentives. So but I think in the past we talked a lot about the social license in the domestic perspective. I think it's a really, I feel the DAC, this is kind of Japanese perspective, but the DAC is a fairly international global technology. It doesn't matter where we place this. So I think the public acceptance issue has a global effect, a global aspect, and that's bad, because I think we can always find places where people don't care about these facilities. So.
Let me go to around to the table around this issue. Maybe Maya, what are your thoughts about the social license? You have mentioned some aspects of this beforehand. So.
Public acceptance is very challenging and highly community specific. So it's hard to make sweeping generalizations about where this is feasible. And I can't attempt to do that. I've got this book, After Geoengineering, by Holly and Buck. I highly recommend, if you haven't already checked out this book. It talks a lot about social licensing. Holly is just an expert in this space. One of the things she talks about is who bears the burden of developing this technology and who's going to reap the benefits of it. I think these are questions that we need to ask ourselves, especially recognizing that there are larger emitters throughout the world. And then there are smaller emitters, and who has the responsibility for scaling this technology, and should we be thinking about that in policy design? So maybe I'm leaving you with more questions than answers, but I'll say these are questions that we need to start thinking about. I don't know that if you ask a room full of people why we should invest in direct air capture, that they would all have the same answer to that question. And so, again, starting to ask these questions as early as possible to decision makers, to influencers, to communities, about what they want to see and what benefits could come to their communities and what trade-offs they're going to see because of the scale of these technologies as well.
Mm-hmm. Ceri, what are your thoughts?
So it's a very interesting question in terms of social license to operate. So I don't think it's the controlling factor in the IEA scenarios, because those are the most cost-effective pathways to achieve emission reduction. So the amount of which technology they think might be most successful tends to vary depending on year, depending on as we learn as we go and what the focus is on their scenario. In terms of CCS, so I see in the Q&A, for example, there's the question about how much we need to store and can we scale up in time. So storing the CO2 isn't the only thing that we need to do. We need to do some of everything. And the question is going to be, what's that going to look like in different places? So in some places we might say, well, actually over here it's more effective to scale up the renewables and that will achieve more of what we want. In some places we might say, well, actually we need to store more CO2 over here because that's more of what we want. And in terms of achieving the social license to operate, it's really being able to communicate to people about what it means. So David mentioned suffering as the kind of third component to this. And I think it's really important to understand what the decisions mean. In terms of having a CCS project, what does it actually look like? What impact will it have? What will it do for you? What are the benefits for the community? In the same way that we would ask, so what are the impacts of having a wind farm here? What are the impacts of having sort of turning this forest into an agricultural landscape? So we kind of have to ask the question, we have to understand, we have to be able to communicate that effectively to people. What does it actually mean if we do this here? And what happens if we don't do this? I think 15 years ago, I spoke to somebody from India who said, we have the first climate change refugees. The sea level has altered, they've been flooded out and they're migrating. We have to understand what's going to happen if we do nothing. And in terms of the cost, we can't just count it in money. So yes, we do, the social license to operate is absolutely critical because you have to put the answer to your climate solution somewhere, be it windmills, be it CCS, be it solar, be it nuclear. You're going to have to deploy these technologies and you have to understand what it means, what it's going to cost and what the benefits are, both locally and globally. Thanks.
Mm-hmm. Thank you. David, over to you. I think you've been thinking quite a lot also on social licensing, so over to you.
Sure. Well, there are some locations in the world where the local license issue may be greatly reduced, such as some of the deserts of the world. But other than those, we're going to be in a situation where the benefits of a DAC project are enjoyed by everyone in the world that benefits from the carbon removal, but the risks and impacts are going to be felt locally. So to get licensed, that means that there needs to be a genuine local engagement process organized and led by people that are trusted by the local community. The first priority, I think, is going to be to demonstrate believably that the operation of the facility, including the storage, will be safe. So you may have a community where you both have the facility itself, which is an industrial facility, and then the storage, which may be underneath the community or nearby. So the community is going to have to be convinced that both of those activities are safe. Technically, it's possible to make a very solid, robust case that both of those activities can be carried out safely. But there needs to be both a credible communicator that engages the community in a way that's believable, shares information which is technical in a way that is understandable. And most importantly, there needs to be the foundation of an oversight activity that is independent of the operators that guarantees the safe operation of these facilities. The third element that I would say is communities are going to understandably say, what's in it for me? Regardless of how safe this is, the facility is still in my backyard and it's benefiting everyone in the world. So the fact that it's in my backyard means that I ought to get some benefits in addition to what everybody else in the world gets. And those could be things like tax revenues. They could be things like shared value of the pore space. The landowner has the pore space rights, typically, as Maya points out. But these flows could be subject to taxes, and those taxes could go to the benefit of the local community. So that's part of the proposition. Human nature is that going to be such that if there are benefits, tangible benefits that flow to the community, then that's going to be something that is going to overcome some people's objections, provided that the threshold of safety is clearly demonstrated.
Thank you very much. So maybe another question in this context is then, how can one assess the approach the question of responsibility? We're talking here basically providing a global good. So how to go about this? Any views more specifically in that regard? And I know that we have two other questions which are not yet covered in the Q&A, and I'll find a way of waving them in shortly. But maybe if we could go around just on that question about the assessing the responsibility or dealing with responsibility for DACCS, and I think the long-term operation of that. I mean, I think we have had some aspects of this covered beforehand in terms of liability, sustainability of the removal, etc. Any thoughts? And if this was one of those, Ceri, did I see your hand there? I'm not so sure.
You did. It's my background sometimes deletes my hand. It's a bit odd.
Okay.
So in terms of long-term liability, I mean, where the CO2 is stored in Europe, the aim is when the storage site operator has demonstrated that the site is moving towards a long-term state of stability, that it will be handed over to the state for long-term stewardship. I mean, obviously, the thinking behind that is, well, if you're looking for something that's going to be around for a long time, you're looking at the church or the state. So it kind of makes sense that it goes to the government to be responsible for the storage site as part of its public good duties. And there is a lot of debate around, so how do we make sure that the liability is handed over? What does that actually look like? And it is an important thing to understand and to make sure that the site is properly monitored and properly managed, that this is done safely. So in terms of liability, yes, it's an interesting problem, and we have run through various test cases, and there are obviously existing projects that will have to deal with this. Sorry, you tapped your ear. Did my sound disappear?
I lost sound.
Okay, can anybody else hear me? Okay, I'm going to hand over to the next person then. Or we wait for Kai to hear us again.
No, don't worry. I mean, I will go with it. Yeah, so maybe somebody else view around this. I didn't hear what you said. So, Maya, thank you.
I can share a little bit. So one of the ideas that's been floating around is this concept of a carbon storage utility. It doesn't exist currently in the US, but it's a very interesting proposition in terms of what Ceri just said, which is, who do you hand over the long-term liability to? I think one of the things that I think about in the context of oil and gas development in California specifically is that we've had a lot of oil and gas developers who leave the state and they basically abandon their old wells. And that's really not what we want to happen. And in the development of direct air capture, we want to have a reliable, stable entity who's going to be monitoring these projects for the lifetime of their, of the injection and then post-injection storage. So when I think about back to this public license question and, getting public perception around direct air capture to a place where we have support for the technology, it's who are the trusted entities who we can ensure will protect the public's interest in the long term. That may be an entity that doesn't exist, that doesn't have financial interest in ensuring that these wells, injection wells, stay monitored, stay safe, for long-term liability, given that we don't know if companies will be around for 100 years. That's just not something that we can answer right now. So I think the public utility option is one that could and should be explored, particularly in California, where we have the opportunity to create carbon storage hubs. So these places where we can have multiple different sources of CO2 coming in, shared infrastructure systems. There's benefits to cost of that. And I think there's also regulatory benefits in terms of accelerating the deployment of these technologies and storage opportunities in specific locations.
Mm-hmm. David, do you also want to come in?
Yeah. So I think we have to think about the structure that motivates the highest level of performance by the operators of the facility during the site selection and injection stages. We have to avoid a situation where the operator, presumably a private company, is relatively indifferent to what happens 20 or 30 years after the end of operations, because some government entity has been set up that, and it'll be that entity's headache, not the operator. So there needs to be a structure that that overcomes that natural tendency to hand off the problem and at the margin make engineering decisions and operational decisions that create greater risks in the future. Mm-hmm. I think that, you know, that's, and we have some, you know, we have some models that are not perfect, but, you know, we do have decommissioning funds, which essentially are funded by a small percentage take on the operations of the facility during the operation period. We have bonding requirements for things like surface mining. You know, these aren't, as we've seen in the United States, these aren't foolproof, because what happens? Coal companies go bankrupt and they discharge their obligations for pennies on the dollar, and all of a sudden these bonds, the residual funds, aren't adequate to clean up the mess they made. So we have to think through all the scenarios where these kinds of things can go wrong, and design a system that creates the greatest number of incentives to for the operators to operate these with an eye to the future, not just what they're doing during the injection period.
Thanks, David. I would want to. I had this things to actually address one point. I said, what are like existing examples from which we can learn in terms of these challenges in the long term, and you basically point to that, where basically a public or other technology has risks and dangers beyond the normal operating context. Nuclear facilities would be one of them, I presume. But I want to do two things. We have about 20 minutes left. I have two questions which haven't been answered. I think, Ceri, I saw your hand also up. I'm not so sure about Maya, but and I will get to that. But first, we have two questions, I think, in the which we haven't addressed from the audience, and as they have been so patient with us and with us all the time, I want to make sure we cover that. One is asking about basically how to deal with emissions in difficult to deal with parts of industries, like is it construction? I think it was transport. Can DACCS help with the fact that there is a difficulty of achieving that? And the other question was, I think, in terms of where is research happening? And maybe if I could have a volunteer first for the second question about where research is happening beyond the points which we, I think, mentioned, the US, the Europe, and Japan, if I understood something is happening. But are there other places? Who is volunteering to react to that? Anything beyond those three? Yeah, Masa.
Yeah, well, so I have volunteered, but actually, to be honest, I don't have any good answer. But I have, I think I have been working on geoengineering, a little different technology, but in terms of governance. And I've heard there's a research program in China and India, you know. But when it comes to DACCS, I've never heard of any research activities in China or India. And I think they have to get serious about it. Because they're going to be the biggest emitters anyway. But I think as far as I know, there aren't any significant research activities in these countries.
Mm-hmm. Any complement to that? If not, then the other question was about what role can DACCS play in the context of emissions of industries which are hard to reduce or to decarbonize. How could DACCS play a role, such as offsets, I think, is one of the considerations, and what implications would this have? David?
Well, first, I think policy needs to distinguish between industries where it might be somewhat more expensive to reduce their emissions than to pursue DAC, and industries where it's either technically infeasible or the costs are extremely high, so high that it interferes with the political consensus to get on with moving to a zero carbon economy. And I think the threshold should be very high. I think that the presumption ought to be that facilities are incented to pursue emission mitigation for their own industries. We don't want to interfere with the dynamic of industries being motivated to find new and innovative ways to reduce their process emissions and to reduce their need for fossil fuel. And if there is an alternative that is cheap enough that they pursue that instead of building up their research and development efforts for their processes, then you created a problem because you've inflated the need for these carbon removal systems, and more importantly, you've dedicated whatever carbon removal systems are deployed to offsetting those emissions rather than to improving the atmosphere by drawing down the CO2. So, this is going to need to be a dynamic system where there remains a push for reductions. Now, it is the case that with current costs of DAC, it isn't all that attractive to many industries to pursue direct air capture as an alternative to exploring ways to more efficiently reduce their own emissions. But we have an objective of reducing the costs of direct air capture. So there's a tension here between the desire to have a low-cost direct air capture system and the desire to improve the ability to minimize emissions in these hard-to-control facilities. So anyway, my response would be to set a high threshold. I would not favor a system that allows DAC to be pursued simply because an industrial activity is somewhat more costly to abate. Great,
thank you. Now I have 70 minutes left. Yes, Ceri, you had your hand up, so I have to give the floor. But before I give you the floor, is that there's one more question I'm going to cover, and then I will go around the table and ask each of you, where do you see DACCS at the mid-century, just before we're entering a global removal era of humanity, and what are the best possible outcomes or the worst possible outcomes in this context, and what governance steps, what are the kind of 2 or 3 key governance steps which you would initiate if you were basically completely in charge in the near future to be at that point in something like 27 years, if you take mid-century very literally. So the order was first Ceri, then I'm going to address the question of Scott, who is in the Q&A, and then we go around the table. We might I hope we can stay in 15 minutes for that. So Ceri, over to you.
Okay, thanks, Kai. I was just going to add on to what David said there about industry, because for a lot of industries, we can apply CCS and capture CO2 from the processes. For example, some of the petrochemicals industries and chemical processes produce a 99% pure CO2 stream that you can pretty much just take and store. So I think David is absolutely right. We should distinguish between the industries where it's really challenging to do that and the industries where we really should just say, hey, let's do CCS while you're developing low-cost alternatives. So you want cement and steel that produces CO2 during the process emissions. Let's do what we can to reduce it, and let's store the rest. In terms of your questions, Kai, where do I see DACCS? So I think that it will be growing simply because we're going to realise that we have no other way to meet our emission targets than to start taking the CO2 back out of the atmosphere. the worst possible outcome for me would be if we start saying, oh, well, we'll just do lots of direct air capture. We don't have to deal with our emissions now. And that would be completely the wrong message for me. We have to deal with the emissions now. In fact, we actually had to start dealing with them 20 years ago, but you know what I'm saying. It's urgent. And what are the next steps to get there? I think for me, it's about looking at what's the most effective way to get this technology in. How do we add it into the portfolio to make this work? So we have our climate targets. I think it's a great idea to have the avoidance and the removal targets separately and to decide what's the most effective way. It doesn't have to look the same everywhere. It's not going, but we have this whole portfolio of technologies. Let's figure out how we use them. Let's use the natural options. Let's use the reduction options. Let's use the removal emissions. And figure out how we get there. It's going to look different everywhere. The incentives are going to be different everywhere, but we have to make sure that we move this forward. Thank you.
Thank you. Then I go with Masa, then go Maya, and then David. So Masa, why don't you go ahead?
Yeah, sure. The DACCS in 2050, I would like to see DACCS to be capturing a gigaton scale of carbon dioxide in 2050, and that would be probably the best possible pathway or scenario. And I'm not so too much worried about the side effects or sort of mitigation deterrence of DACCS, because I just can't, maybe I'm wrong, but I can't imagine a scenario where DACCS costs will fall so rapidly compared to other mitigation opportunities. And other mitigation technologies are falling down in their costs. So I think there will be more opportunities for this emissions reduction. So probably the worst situation would be no DACCS at all. So like I said before, the startup companies, they just die. They will die at some point in time because of lack of policy support. Yeah, and the key governance challenges, I think right now it's, let me reiterate, the companies need, like David said before, I think we have to create a market to support the companies to develop. And of course, we have to consider all the side effects carefully, and we have to create a very nice, decent policy framework, but we need to support DACCS companies, because otherwise we wouldn't see the development of this technology by 2050. So thank you.
Thank you, Masa. Maya.
Sure, I want to try and address Scott's question, though I think, Scott, you might be well equipped to answer this question yourself. I'll say in California, the assumptions that are being made in the models right now is that only renewables are able to power direct air capture. I think that's a huge missed opportunity to understand what electricity and heat trade-offs could come from different sources, especially from a land use perspective. So I don't have a solid answer for you, but I think it's one that we need to be asking ourselves and exploring, is around what operational improvements are available, as David's mentioned, and then what are the different trade-offs with existing systems right now. I think my big focus in terms of getting, I just lived through the California wildfires, and to think that this is the best that it's going to be is a pretty scary thought for me. And so I really think we need to start asking ourselves these hard questions right now, because whether or not we right now believe that direct air capture is necessary to achieve mid-century goals, I mean, we absolutely owe it to future generations to keep this technology on the table as an option and to explore all of the benefits and trade-offs that could come from it. Some of these questions will take time to answer, and some of the operational improvements that we need to scale this are going to take money and time. And so starting that like yesterday is essential. Especially as we're seeing people really suffer the effects of climate change across the globe, and increasingly so. So my worst fear is that we don't do by mid-century, that we haven't done the research, we don't invest because we don't think we need it. Because again, I don't think we can predict out to 2050. I don't think the models are reliable out to 2050, really. I think we just need to start doing the research now.
Thank you, Maya. David?
Well, thanks. Ceri and Maya made excellent points. I'm glad this is being recorded. I don't need to repeat what they said. I just encourage people to listen to the recording. 2 quick points. First, on policy, I think we need to set ambitious CDR targets on top of ambitious emission reduction targets. And second, we need right away to adopt policies that will speed the deployment of pioneer DAC projects, get them up and running, and get the process started for learning and reducing all of the costs and energy requirements. Thanks very much.
Thank you. This is now actually we're the end of our campfire. We are slightly early. We have dealt with the additional questions. I don't want to kind of summarize all our findings, but and this part is not to say that I will. So I think I will just want to thank all of you to have taken the time to share the thoughts, go through these various questions and thoughts. I mean, it becomes apparent and clear that DACCS is clearly one of the technologies which are, as somebody said, on the table. And governance need to start yesterday. I think a point which our initiative is making for a few years, and some doors closed 3 years ago, which are now opening. So I think there is some positive space, but it is, as you said, it's 25 years from now on where you want to have it operation. I always say that my kids have my hairstyle, so to say, in terms of color. They will be living a world where this all is resolved and it's operating, and they don't have to worry about actually moving into the phase when this becomes bigger than what we are still emitting. So in that terms, this is a massive change. And as you, I think Maya or somebody said, our models are techno models to a large extent, and they, which are good, which they give us the options and opportunities. But then there's this whole work to drive the real understanding, work with the understanding of that we have to do it. And with all of this, I think I would like to close, unless any of you has one more last remark. We have, I think, time for one last thought before we close the event. If I don't see...
Just get busy.
All right, on that note, let's get busy and move on. Thank you, everyone, for your time for this campfire, which will be on record, on demand, available. And we had decent participation. Some 10 people were out there with us, and but it will be reused a lot in going forward. Definitely our initiative is going to use this in terms of also capacity building, awareness raising exercises. So thank you very much for being part of it, and we're looking forward to other interactions we might have with any of you and some of the participants, of course, as well. Thank you very much for your time.
Thank you.
All right.
Thank you.
Thank you.